My student Sahana asked me an interesting doubt on this question. This is an old JEE question. Let us look at the question carefully. If 1 minus p is one root of the quadratic equation x square plus px plus 1 minus p equal to 0, then find its other root. There are 4 options given here. What is Sahana's doubt in this? Let us look at that. You have been given this quadratic equation. If you have a quadratic equation ax square plus bx plus c equal to 0, then you know that the product of roots must be c by a. This is well known. And so Sahana argues that if I look at this quadratic equation, then the product of roots for this quadratic equation must be 1 minus p by 1, which is 1 minus p. I already know that one of the roots is 1 minus p. If the other root I call it as beta, the product of roots will be 1 minus p into beta. But that must be 1 minus p. So cancelling this 1 minus p, I'll get beta equal to 1. One root is 1 minus p. The other root must be 1. So that must be the answer. There is an option given here. Unfortunately, this answer is wrong. And so Sahana's question is, why is my answer wrong? What is wrong in what I have done? Can you pause this and figure out why Sahana's answer is not correct? Because this is an old JEE question, there are lots of websites, videos, and books where you can see the solution for this question. Let us first look at the usual solution that is presented. The usual solution starts by recognizing that 1 minus p is a root of this quadratic equation. What does that mean? You can substitute 1 minus p instead of x. So you can write 1 minus p whole square plus p times 1 minus p plus 1 minus p must be equal to 0. And so 1 minus p is common. You can pull that out and you can factorize it and write it as 1 minus p times 1 minus p plus 1. Okay? Now this minus p plus p will cancel out, giving you 2. So 1 minus p into 2 is equal to 0. So what does that tell you? It tells you 1 minus p must be 0, p must be equal to 1. So you can actually solve this and find out p is equal to 1. Well, if p is equal to 1, look at this quadratic equation. 1 minus p is 0, p is 1. So the quadratic equation becomes x square plus x is equal to 0, which means x into x plus 1 is equal to 0. So that means the roots are x is equal to 0 or x is equal to minus 1. So you actually got both the roots, 0 and minus 1. And we know that 1 minus p is one of the roots, that is the given root. P is 1. So if I substitute for p equal to 1 here, right, you're going to get 1 minus 1, 0. So 1 minus p, 0 is the given root. Since the two roots are 0 and minus 1, the other root must be minus 1. And so that is the answer to this question. Is this a solution? Yes. Is it a correct solution? Yes. But the problem is, this tells you how to solve it in a different way. It doesn't really answer Sahana's doubt, right? Sahana's doubt was, why is her method wrong? Because she used product of roots. So why is that wrong? Giving her a solution like this doesn't answer her actual question. So let us now focus on Sahana's solution and try and find out where did she go wrong. For this question, Sahana came up with the answer that for that quadratic equation, the other root must be 1, which turns out to be wrong. But what was the mistake in Sahana's solution? Let us look at that step by step. Okay? So first Sahana said that this quadratic equation, the product of its roots must be c by a, which must be 1 minus p by 1. This step is correct. Then she argued that it is given that one of the roots is 1 minus p, let the other root be beta. So the product of roots must be 1 minus p into beta, but we already know it must be 1 minus p. So she came up with this equation, 1 minus p into beta, which is the product of roots, must be c by a, which is 1 minus p. This step is also correct. So obviously you have 1 minus p on both sides, and so she concluded that beta must be 1, and so the other root must be 1. Now that step is wrong. Why is that step wrong? You have 1 minus p into beta equal to 1 minus p. So how did she get beta as 1? She cancelled 1 minus p on both sides. But when can you cancel the same number on both sides? Only if this number is not equal to 0. So you are allowed to cancel only if 1 minus p is not 0. This condition is very important, right? So if you want to cancel 1 minus p, remember that is only possible if 1 minus p is not 0. But 1 minus p could be 0. So actually we get two cases here. So the first case is 1 minus p is not 0, in which case you can cancel and then you get beta equal to 1. This is what Sahana did. But you also have another case. And the second case is 1 minus p is equal to 0. But if 1 minus p is 0, what is beta? Oh, you can't find out, right? Because if this is 0, you get 0 into beta, which will be 0. And that side will also be 0. So case 2, 1 minus p is 0. Beta can take any value. So you actually don't know beta. So when I explained this to Sahana, immediately she said, okay, maybe there is a case that I missed out, but this case is also correct. No. So why can't I say beta is one of the answers? So this could be one of the answers. So it should still be correct. No, because if you only look at product of roots, you're only looking at one condition. Please remember, for a quadratic equation, product of roots must be c by a, but there is a second statement, which is the sum of roots. So sum of roots must be minus b by a. So let us use this for case 1 and case 2 and see what happens. Okay? If you stop with just product of roots, it looks like beta equal to 1 is also a possible answer. But when you apply it to sum of roots, you will see that there is a problem. Okay? What is sum of roots minus b by a for this quadratic equation? Minus b by a will be minus p by 1. Minus p by 1 is minus p. Right? So this must be the sum of roots. But if I now look at the sum of roots, one root is 1 minus p, the other root is 1. For case 1, one root is 1 minus p, the other root is 1. So what will be the sum of roots? 1 minus p plus 1. What do I have here? Minus p, and you have a minus p there. So you can cancel these two. Then what do you have on this side? 0. And what do you have on that side? 2. So you end up with 0 equal to 2. So if you actually say case 1 is the correct answer, you end up with a contradiction because you get 0 is equal to 2 when you apply the second condition. Sum of roots must be minus b by a. So obviously this is not possible. Case 1 is not possible. That is why Sahana's answer is invalid. Let us now look at case 2. Maybe that gives us the answer, right? But wait a minute, that doesn't give us anything because you're not getting beta. So just using this, we cannot figure out anything. We of course know that 1 minus p is 0. So one of the roots is 0. But we still don't know what is the other root. For that, I have to use sum of roots. So what is sum of roots? Well, minus b by a, it is minus p by 1. But what is the sum of roots here? 1 minus p plus beta. 1 minus p plus beta. I don't know what is beta. Okay. But this is minus p. That is minus p. I can cancel that out. So I'm going to get 0 is equal to 1 plus beta, which means beta must be minus 1. So I found out that the second root must be minus 1. I didn't get it from product of roots. I got it from the sum of roots. Of course, the product of roots told me that 1 minus p is 0. But the sum of roots tells me that beta must be minus 1. In fact, this is not even a possibility. That is the only possibility. So that means the two roots of that quadratic equation, they are 1 minus p, which is of course 0, and beta, which is minus 1. So the roots are 0 and minus 1. One root, 1 minus p, was already given, which is 0 in this case. So the other root must be minus 1. So the correct answer to this question is option C, minus 1. So the other root is minus 1, not 1. Okay, I hope you understood both the solution and what was the mistake that Sahana had made. If you like this video, please hit the subscribe button below and If you have similar doubts or questions in physics or math, please post them in the comment section below. I will take the most interesting question and make my next video. See you all in the next video.